All right, let's take a look at chapter 22, Inference about a population proportion. A large sample All right, let's take a look at chapter 22, Inference about a population proportion. In chapter 22, we cover the sample proportion, p hat, large sample confidence intervals for a population proportion, choosing the sample size, significance tests for a proportion, plus 4 confidence intervals for a large proportion. The sample proportion the sampling proportion p hat. The statistic that estimates the population proportion p is the sample proportion p hat, which equals the number of successes in the sample divided by the total number of individuals in the sample. Sampling distribution of a sampling proportion. Draw an SRS of size n from a large population that contains proportion p of successes. Let p hat be the sample proportion of successes. P hat equals the number of successes in the sample divided by n. Then, the mean of the sampling distribution is p. The standard deviation of the sampling distribution is the square root of p times the quantity 1 minus p divided by n. We note confidence intervals for a population proportion. We note the standard deviation of p hat depends on the parameter p, a value we don't know. We therefore estimate the standard deviation with the standard error of p hat. The standard error of p hat equals the square root of p hat times 1 minus p hat divided by n. Large sample confidence interval for a population proportion. Draw an SRS of size n from a population having unknown proportion p with some characteristic. An approximate level C confidence interval for p is p hat plus or minus z star times the square root of the standard error of p hat, where z star is the critical value for the standard normal density curve with area C between negative z star and z star. Use this interval only when the number of successes and failures in the sample are both at least 15. Choosing the sample size. The margin of error in the large sample confidence interval for P is M equals Z star times the standard error of P hat, which is the square root of P hat times 1 minus P hat divided by N. Here Z star is the standard normal critical value for the level of confidence we want. Sample size for desired margin of error. The level C confidence interval for a population proportion P will have a margin of error approximately equal to a specified value M when the sample size is N times Z star divided by M squared times P star times 1 minus P star. where P star is a guessed value for a sample proportion. The margin of error will always be less than or equal to M if you take the guess P star to be 0.5. Significance tests for a proportion. Draw an SRS of size n from a large population that contains an unknown proportion P of successes. To test the hypothesis that P equals P naught, compute the Z statistic. Z equals P hat minus P naught divided by the standard error for P hat. Well, the standard error for P naught, which is the square root of P naught minus 1 minus P naught divided by N. In terms of a variable Z having a standard normal distribution, the approximate p-values for a hypothesis test of H naught against the alternative hypothesis that P is greater than P naught, here shown in the image, where the critical region is the region greater than Z, and the p-value is the probability that a z-score is greater than the z statistic we computed. Or a test against the alternate hypothesis that p is less than p naught, shown in the image here as the critical region less than z statistic we computed. And the p-value is the probability a z-score is less than this z statistic we computed. That's the one we actually get from the table A. So that's always the nicest test to run. And also we have a third test, which is the two-tailed test, or the alternative hypothesis that P is not equal to P naught, which gives us a critical region above and below the z-score, positive and negative, for the z statistic we computed above. And our p-value is 2 times the probability that a z-score is more extreme than this z-score. Plus 4 confidence interval for a proportion. The confidence interval p hat plus or minus z star times the standard error for p hat, which is the square root of p hat times the quantity 1 minus p hat divided by n, still under the radical. For a sample proportion p, the confidence interval for a sample proportion P is easy to calculate and understand because it is based directly on approximately normal distributions of the sample proportion. Unfortunately, confidence levels from this interval are often inaccurate unless the sample is very large. The actual confidence level is usually less than the confidence level you're asking for in choosing Z-star. There is a simple modification that is almost magically effective in improving the accuracy of the confidence interval. We call it the +4 method because all you need to do is add 4 imaginary observations, 2 successes, and 2 failures. The +4 estimate of P is number of successes in the sample plus 2 divided by n plus 4. Using the +4 estimate of P, number of successes in the sample plus 2 divided by n plus 4. Plus 4 confidence interval for a proportion. Draw an SRS of size n from a large population that contains an unknown proportion p of successes. To get the plus 4 confidence interval for p, add 4 imaginary observations, 2 successes, and 2 failures. Then use the large sample confidence interval with the new sample size n plus 4. And number of successes, actual number plus 2. Then p tilde plus or minus z star times the square root of p tilde times the quantity 1 minus p tilde divided by the quantity n plus 4 is our confidence interval. Use this interval when the confidence level is at least 90% and the sample size n is at least 4 with any counts of success and failures.